Our objective for today, I can multiply polynomials. Read together. 1, 2, 3. I can multiply polynomials. So today we're going to finish the second part of multiplying polynomials. And like I said before, we don't need the Freyer model because we already have that. We don't need the steps because we already have those too. Yesterday we distribute. Is that correct? From there we identify like terms. You use commutative and associative properties to combine like terms, and at the end we simplify. Okay? Today is going to get a little bit more exciting, funner, and you'll see when we get there. But let me just recap what we did yesterday. Yesterday I showed you this one and this one using tiles, distributive property, and area model. Is that correct? By the time you got to these, I said do those just with distributive property and area model. From there we went to these, to this, to these, to this. From there we went to multiplying monomial times trinomial again, and we ended with this one. So with that said, copy this one please. Example 2D. And it says, multiply 3ab times 5a squared plus b, close parenthesis. So just to get our noodle going, let's do this one first, distributive property. So I'm going to multiply this times the first term. So what is 3 times 5? 15. A times a squared. A to the third and b to, there's nothing there, so I just write the b right there. Now the same factor times the second term. What is the coefficient on the second term, everyone? 1. So therefore, 3 times 1, that is positive 3. A times, there is no a, so I just write the a right there. And b times b becomes b squared. And let's use the area model. Oh. There it is. So I have 3ab, 5a squared plus b. I draw my line down. Therefore, I start with this times this. So 3 times 5, that's 15. A times a squared, that's a cubed. And I write the b right next to it. Coefficient of 1. Therefore, 3 times 1, that's positive 3. A, there is no a on that second one, so I just write it. And b times b, that's b squared. And we're done. Is the area the same as what we got as a product over here? Yeah. We good? All right. And then copy this one, example 2F. And do this one using any method that you like. You want to use the area model, use the area model, or distributive property, distributive property. See if you can do that one by yourself. Go. That's y, I'm sorry, tell me what y squared, it's y cubed. So we distribute, and this is our product. Hands if you got that. Okay? So now that we're done with these easy ones, copy this next one, please. Boom. Example 3a. Yes, I just did. I said copy this one, example 3a, and it's parentheses s plus 4 times s minus 2. Just copy it. I'm going to go over this one first. All right? So I'm going to do this both ways. I'm going to use distributive property, and then I'm going to use the area model. So check this out. First, I'm going to start with distributive property. Watch. Who notices now that this factor no longer is one monomial? Now it's a binomial. Did everybody notice that? In the previous one, it was only a monomial. Let's go to the previous one. Look at that. Do you notice that it's only a monomial? And the previous one before that, also only a monomial. Now we're at binomial, okay? So check this out. If I use distributive property, I'm going to use the first term first, and I'm going to do this. Distribute to this term. So what is S times S? S squared. You're just paying attention right now. I'll let you copy a little bit. S times negative 2, that's negative 2S. So far, so good? So I'm done with this one times these two terms. But now I have another term. So I'm going to multiply this one times these two also. Instead of going this way, I'm going to do underhooks right here. What is 4 times S? Plus 4S. What is 4 times negative 2? Negative 8. Are we there so far? Now, before I go any further, look up. I want you to write, once you do this, what did we do? We multiplied. Are we there? Copy that, please. All right, pens down, eyes up here. Now, this is where I start losing some of you, so please, pretty please, pay attention. Here it goes. Like I said before, we were going to get to some problems where we combine all the properties that we've seen. So let me ask you this. When we multiply, what is it that we've been doing to these exponents when we multiply with same basis? We add, right? We're doing stuff with the exponents. Are we there? Okay. Now that we multiplied, we're done with multiplication. Tell your neighbor what I just said. So now we move to the next step. Check this out. The next step is to add or subtract. So pay attention to this part. When we add or subtract, we no longer do anything with exponents. Now we're going to combine like terms. So, is there another S squared here? No, I just rewrite it. All right. Here's a S. Is there another S? Yes, so I write it once. And since now I don't do anything to the exponents, now I focus on the coefficients. Negative 2 plus 4, that is positive 2. And then at the end, I just bring the negative 8 down, and I'm done. Copy that, please. All right. So now, we got distributed property down, right? All right. So now, I'm going to go now and do area model. I'm going to do my area model over here of a rectangle. We can do this one together. Area model. Model. Okay. So, what was the side length? It was S plus 4. How many monomials do we have in this binomial? 2. 1, 2. So to distinguish one from the other, I draw my line across. What is the measurement of the length? S minus 2, and I draw my line down. So now who notices now we have 4 different little areas inside? Everybody see that? If you don't see it, watch. Look up. Let me show you. If I was to cover this and this, do you see that little area right here for the S times S? Yes? Same thing if I was to move this one over this way. S times negative 2 is this area. Do you guys see it? Okay. All right. So that's why I go like this. S times S. What happens to the exponents when we multiply? We add, so this is S squared. What is S times negative 2? Negative 2S. Next, this one times these two, so 4 times S, that's 4S, and it's a positive. And what is 4 times negative 2? Negative 8. Now, if I write it out, it's going to be all this. Look up, please. Do we have an S squared? Yes. Do we have a 4S? Yes. A negative 2S? Yes. And negative 8. But at this point, you can actually simplify really fast by saying these are like terms. And I'm going to draw a little peanut right here. There it is. And since these are the same, I'm going to write S. And what is 4 minus 2? 2. And it's a positive. And all I have to do at this point, I bring down the first term, S squared, and I bring on the last term, negative 8. Did I get the same thing in here? Yes. Copy that, please. So, any questions with binomials times binomials? Okay, let me give you one for you to do by yourself. Here we go. Example 3Q. Parentheses, x plus 5 times x minus, somebody give me a number? 2. Be nice. Oh, bam. It should be extra credit, but no. Okay. Finish up, please. That one is x plus 5 times x minus 2. Do those with distributive property and area model. Copy that and go. All right, let's see. The product of these two factors, let's see. X plus 5 times x minus 2, you should have gotten x squared plus 3x minus 10. Hands if you got that. That is correct in both ways using distributive property and area model. Okay? Copy this one. Example 3b. Says parentheses x minus 4, close parentheses, squared. Now be careful with this one because this one's starting to pull your noodle to something that's familiar, which is this. Look up. Some of you are looking at it, you're like, wait a minute, I can do this. That's wrong. So don't do that. Let me explain it like this. If I have 2 cubed, what does that mean? 2 times 2 times 2, is that correct? If I have this inside instead of a 2, this tells me to do that how many times? X minus 4 times x minus 4. Does this look familiar? Bam! So copy that, finish it off, please, and choose whichever method, area model or distributive property. Go. All right, let's see. X times x, x squared, x times negative 4x. Then I got negative 4 times x, that's negative 4x. Negative 4 times negative 4, that's positive 16. So far so good? X squared, there's no other. This is the same as this, so I combine these two to x, that is negative 8. And I bring down the 16, hands if you got that. Okay. Who used the area model? Distributive property? Okay, the majority. All right, let's go to the funner stuff. Here we go. Copy this one. Example 4a. And we have parentheses x minus 5, close parentheses, times x squared plus 4x minus 6, close parentheses. And we're going to do the area model for this one. Yay! So draw a long rectangle like so. There you go. And let's write on the side, let's write x. And look what I'm going to do. Instead of writing the negative here, I'm going to write it next to the 5. Why? So that I don't forget to include the negative with that 5. Draw your line across. And what goes on top? X squared plus 4x minus 6. So now how many terms do we have? 3. So after the first term, a line down. After the second term, a line down. And now we have our area. So let's start. X times x squared. X to the third. X times 4x. Positive 4. What else? X to the what? Squared. X times negative 6. Negative 6x. Okay, so we're done with that term. Let's go to the second term. Negative 5 times x squared. Negative 5x squared. Negative 5 times 4x. Negative 20x. And negative 5 times negative 6, that's positive 30. Okay, hold on. Without rushing out, check this out. Do we have like terms here? Yeah, so draw one peanut right here so that you know you're going to combine those. Is there another like term? Yeah, so you're going to do another one on these, and you're going to combine these. We're going diagonally, so let's see. X squared, negative 5 plus 4, that's negative 1. These are x's. Negative 20, negative 6, that's negative 26. All we have to do is bring down the positive 30 and bring down the first term, which is x cubed. Bam! Home plate for tonight is on page 506 to 507, and now you're doing the 1 through 22 evens. Have a good one, everyone. See you guys at the assembly or tutoring. If not, see you guys tomorrow.